Hey guys, how's it going? Welcome back. We're going to go over chapter 134 today, hydraulic components and control systems. Okay. So we're just going to talk about basically about hydraulic principles and how we utilize the different ways that we actually can control we can control certain circuits and parts of an automatic transmission just by using hydraulic principle, which basically means the movement of energy through a liquid. So in that case for us, the liquid is actually an automatic transmission fluid. That's why I was saying, I think in the last lecture, that the transmission fluid is probably the most important part or component of an automatic transmission. Without fluid in a manual transmission, it'll still work. It's not going to work long because there's lack of lubrication. But with an automatic transmission, you're not going to get any function of it at all without automatic transmission fluid in it. Automatic transmission fluid is routed from the torque converter, where most of the heat is generated, to the radiator where it is cooled. The fluid then returns to the transmission/transaxle to lubricate the bearings and bushings. So they're showing you one type of setup for the cooling system itself, or the transmission cooler system. It'll actually come out under pressure, go through the actual radiator, and it's going to have the vanes that, just like as if you were working like a regular radiator lets the coolant go through. It'll pump through, air passes through, cools down the fluid, comes out of the radiator, goes back into the transmission. Heat is probably one of the #1 killers of automatic transmissions. We want to minimize the amount of heat that the transmission is going to be absorbing. So the best way to do that is to actually take the radiant heat out of the fluid and then put it back into the transmission, hence cooling it. A cutaway of a typical radiator showing the automatic transmission cooler. The heat from the automatic transmission fluid is released to the engine coolant. The engine coolant also warms the fluid as soon as the coolant flows through the radiator. Now there are two different types of transmission coolers. One of them is going to be built into the radiator like so. So as the fluid goes in and goes out, it's going to be cooled down and also warming up the fluid. But also we have a separate style transmission cooler. It's they call it a remote transmission cooler. So it's actually separate. It's basically a mini radiator. It looks just like a regular radiator, but instead it's actually either in front or in back. It's usually going to be in the front. You want that fresh air, cooling. The cooler the air goes through the transmission cooler, obviously the cooler the fluid is going to be when it goes back into the transmission. Engine coolant from the engine block flows through the passages in the cooler/warmer and then through the thermal valve into the upper radiator tank. The thermal valve uses a wax element type valve to control the flow of engine coolant through the case-mounted mounted cooler/warmer. The thermal valve improves the ATF warm-up times and maintains ATF temperature within the optimum operating range between 170 and 190 degrees Fahrenheit, or 77 and 88 degrees Celsius. So the thermal valve is kind of like a thermostat for an engine. As you have coolant goes through, it keeps the coolant inside the engine block while it's waiting to warm up. Once it warms up to a certain temperature, then it will allow it to go through. Same thing comes into play with an auxiliary cooler. The thermal valve will open and close as it sees fit as far as temperature. So if it's too cold, it's going to allow it to stay in the transmission longer to warm up, and as soon as it starts to warm up, it's going to open the valve and then allow it to actually come through the cooler, goes back into the transmission. So it's to help monitor and maintain temperature. The reason why is you don't want it too hot, but you also don't want it really cold. My old Durango and the Dakota, actually, both of those, they tend to not work as great. The transmission would slip a lot more when the engine and transmission were cold. But once the engine and transmission started to warm up, once it got up to operating temperature, I wouldn't say it didn't slip, it just slipped less. So definitely that's why we want to wait in the morning, let our cars warm up, because they run a lot better when they're warm. Operating temperature can range anywhere from say 170 to 190, maybe 195, maybe 200. It all depends on the different manufacturers and their specifications. So 170, 190 is more of a ballpark for most cars. but some of them may want it to run a little cooler, or some of them may want it to run a little warmer. It just depends on the manufacturer. Transmission pumps. This pump is actually it's set inside the transmission, usually on the output shaft. Remember how I told you guys that the torque converter is going to rotate and spin this gear itself. Now you see these little grooves here. If you remember when we were talking about the torque converter and I showed you those two little flat spots, that's where this engages. And as this rotates, what it's going to do is it's going to pull transmission fluid in one side, pressurize it, and then push it out the other side and either send it through the torque converter or into the transmission itself. So this is a gear type pump. So it actually uses gears. When it rotates, it's actually meshing together with the outer ring and the sun gear in the center, pressurizes the fluid, and then pushes it out. A rotor type pump, it's kind of the same concept. It uses somewhat of a gear assembly, but it does pretty much the same thing. You see you have the two grooves here. As it rotates, pulls in fluid one side, pressurizes it, and sends it out the other side. They all work with the same concept. They're just taking it and passing it through itself and then sending it out. A vane type pump, same thing. Fluid comes in, pressurizes, and gets sent out. So in order to, you could say, in order for it to maintain pressure and not to burn out the pump, you need to have fluid flowing through this pump constantly. That's why if you have low transmission fluid, or say no transmission fluid, when you first initially start the car, you could run into the possibility of burning up that pump. So you want to make sure that you do have fluid in the transmission before you start the vehicle. When pressure on the face of the pressure regulator valve overcomes spring force, the valve moves open to the exhaust port. This is where we get into the hydraulic concept. So this spring, okay, this spring is applying pressure this way, in this direction. So it's closing off this little port here. When pressure builds up and increases, it's blocking this port's opened up. So when pressure builds up and starts to increase, this is going to overcome spring pressure. It's going to open up, which then allows the exhaust port, or it's going to open up the valve pretty much and allow the fluid to pass through. And the pressure regulator, I don't want to say the pressure regulator, but a lot of parts in the automatic transmission rely on this method or this concept of being able to apply spring pressure, closing off a port, and then when pressure gets increased, like say if you're accelerating, the pump's turning faster and faster, it's going to generate more pressure, so it's going to overcome that spring pressure and allow the valve to open up, hence actually allowing it to switch to the next gear. The variable pump is at a maximum output position until the regulator valve moves close enough to decrease volume by rotating the slide against the force of the priming spring. The position of the pump constantly varies depending on the needs of the transmission and transaxle driving conditions. So as this pump is rotating, basically what they're saying is we're monitoring and we're regulating pressure just like we are with the thermal valve on the actual cooler. We want to be able to apply pressure, but not too much. We had a customer come in, we got a transmission rebuilt, but the gentleman who rebuilt the transmission, he actually forgot to put in the pressure regulator valve. And when instead of having, say, a monitor pressure of about 150 to 200 PSI, we went about 500 PSI throughout that transmission. We were surprised that when we put it in a drive, it didn't just grenade the entire transmission. So we definitely want to monitor pressure, and we want to be able to control and regulate pressure. So that's basically what they're talking about, where the variable pump, we're being able to change the pressure when needed. The pressure control solenoid controls the mainline pressure, which is in turn controlled by the powertrain control module, or the transmission control module, or TCM, by applying pressure to the spring on the side of the pressure regulator valve. So now we're actually using electronic solenoids to control pressure as well. This is going to be more common now than, say, the original style of just the spring overcoming the hydraulic pressure overcoming spring tension. We can actually control it and we can open and close this very fast, and that's where we can control and raise and lower the amount of pressure being generated. So it's more or less of an open and close. It's, if you open and close fast enough, it's as if you have a water hose, right? You plug it, it's not flowing anymore. You let some through and you close it. If you do it fast enough, you can control the amount of fluid that's actually coming out. The same thing comes into play with the pressure solenoid. You can control the amount of fluid that's passing through the solenoid. Gear set members are attached to a drum and held stationary when the band applies. So now we're talking about a very vintage, I won't even say vintage, it's a stupid word. A very primitive design on how automatic transmissions used to work. We have the rear sun gear, we have the portion of the shaft that's going through this housing, which is the input shell, the front sun gear, the reverse clutch drum, and the intermediate band. This band is actually surrounding this reverse clutch drum, so when you actually apply and shift it into a certain gear, this band will grab onto the drum, holding it stationary. When it holds stationary, it allows you to actually shift the vehicle into reverse. So this band is just like a clutch pack, that it has the material and then you have the steel material in between each one. But the material right here is the actual clutch material, and then you have the steel drum. That band grabs onto the drum, holding that drum stationary. Transmission bands come in several designs and thicknesses: a split band or a double wrap, thick heavy band, which is a single wrap, and the light thin band, which is also a single wrap. Now, it's kind of hard to explain. Like, well, these are obviously the thickness and the thickness of each band is going to determine on how much it actually grabs. Obviously, the thicker heavy band, which is still a single wrap, means it just goes around one time. This one here is definitely going to grab a lot harder, so this transmission may shift a lot firmer compared to the single wrap. This one may be more of an economic transmission, allowing smoother shifts. It's not so aggressive, you know, little old lady driving her, 59 Cadillac. They're going to want the light fin single wrap to allow for smooth transitions into each gear. The split band double wrap, it's not necessarily wrapped twice, but each portion, you have two bands that come around like this, and then one band in the center. So they actually link up pretty much like in this formation. So this one loops around to the back side of this one. These two loop around to the front side of this one. A servo uses hydraulic pressure to move a piston, which applies a band. So the servo itself is the one where pressure buildup is going to increase and overcome the spring pressure that's on the piston, and when it starts to apply, it's actually going to grab the band, which then shifts into the next gear. One end of a band is held stationary and the other end is attached to a servo. So as this drum is starting to spin, the servo is going to apply pressure. When it applies pressure, it's going to grab. When it grabs, it's going to hold that drum. It's going to shift it to the next gear. Some vehicles have two bands, some of them have one. It just depends on the transmission. And these can be adjusted from the outside. You're going to see on older style transmissions, you're going to see a little dial out here. And you can actually adjust it because through time, the material inside that actually starts to, if it starts to slip, it's because it's not grabbing tight enough, because you haven't adjusted it yet. So if you adjust it, this works its way in, which then makes it smaller. Making it smaller means when it engages, it's going to grab on tighter. If it grabs on tighter, it's going to slip less. An exploded view of a multiple clutch plate pack assembly. I've already kind of gone over this. I went over it last week, you guys. But the clutch pack itself, you got the steel plates, you got your friction disc. They're all compiled together, put inside the clutch drum, and then put a snap ring on it. So I'm not going to get too much into it. We kind of already brushed over it a little bit if you guys have been going to my Zoom meetings. Definitely, when repairing these and rebuilding, you want to put them in the correct order. If you have the order off or you have it wrong, you're definitely going to run into some issues. More likely, you're going to damage the transmission. Typical clutch pack assembly. So this is one we just saw. As you can see, each one of these little grooves, it sits inside, and they mesh up with an outer, not to say outer housing, an inner housing inside that matches each one of these grooves. And when the clutch plates engage, it grabs it. Basically, this pack here is like the drum and the band clamp basically this one here. So the band that's going around the housing is pretty much the same concept as using the clutch packs. Hydraulic fluid under pressure enters the clutch housing and exerts force on the clutch piston. The clutch piston forces the steel plates and friction plates together, creating a shift. Excuse me. In a holding clutch, one set of discs engages splines on the transmission case, and the other set engages splines on the drum. By applying the clutch, the drum is locked into the case. An integral accumulator. So this is actually where we get in a servo single bore in the transmission housing. This is where we actually create and monitor pressure as well inside the transmission. If you think about an accumulator for brake systems, where we have like a hydro boost system, that has an accumulator on it. It's made to hold and maintain high pressure or pressure for your actual brake application. It works in the same concept of creating pressure and holding pressure up to a certain amount. Roller one-way clutch in lock-held position. Note that the rollers are wedged into the ramp as machined into the outer support. I'm just going to kind of breeze through this, you guys. I know it's a little tricky to understand. Here's the valve bodies. Now, when it comes down to the valve bodies, it looks like a giant map or just a big spaghetti factory. But each one of these is actually a passageway where transmission fluid is going to be traveling through, going to being able to send pressure where it needs to go inside a transmission. So one of these, like 2 or 3 of these may be actually for, say, first gear. A couple of them maybe for second gear, third gear, overdrive, reverse. So these are all just passageways for, think of like a labyrinth, which is a maze. You know, there's only one correct way for it to go, but you still have multiple and other spots. Like, obviously some of these are just because you're trying to create the path for somewhere else. But a lot of these, when you have the lid on it, you're going to have fluid passing through, basically just like a giant maze for the fluid to pass and to get to where it needs to go in the transmission. Electronic controlled automatic transmissions use solenoids located in the valve body to control line pressure, to open and close passageways in the valve body to control shifts. Each one of these is a shift solenoid, and these ones as well. When you are driving, you put it in a drive. One of these valves will open, allows fluid to pass through the valve body, then obviously giving you first gear. When you come up to a certain speed, certain RPM, certain amount of load, the signal gets sent to the solenoid pack itself. It says, hey, we're going to go into second gear. Second gear engages. That allows fluid to go through the valve body, engage second gear, and so on and so forth. Now these, a lot of these are serviceable. Like let's say first gear goes out. I'm not saying this is first gear, but just say, obviously these activate certain gears. Let's say this is first gear and it goes out. Some of them we can replace these. You unbolt it here, slide out the solenoid, put in the new solenoid. Some of them you don't even have to pull apart the transmission to replace them. I did one on a Ford, I believe. Their solenoids are actually on the outside. The 1-2 shift solenoid, so from first to second, that solenoid went bad, so I went under there, found out which one it was, disconnected it, put in a new one, test drove it, it was fine. So some of these can be replaced without really doing too much tearing into or tearing apart. Some of them you gotta drain the pan, obviously pull the pan off, replace the solenoid because it's on the side of the valve body, put it all back together. But it's still a lot better than having to blow apart an entire transmission for a $40 solenoid. Check valves are used on the valve body to allow hydraulic circuits to share a common passage. A rooster comb is a detent that helps retain the manual valve in the various positions of the valve body. So the rooster detent is actually how we engage and disengage each gear. You know, when you shift on a column shift car, as you shift into first, second, third, you know how it kind of like locks and you can feel it slide up and down? This is actually the rooster detent. This is what they're talking about. It's shifting in each available gear. So this is park, reverse, neutral, drive, or overdrive, drive, first, second. So each one of these is actually a position in a vehicle, so you can actually manually shift into first, second, third, drive, so on and so forth. The manual valve body is a spool valve that is moved up in shift linkage. All the valve in the valve body has sharp edges on the lands. Any dirt in the valve body area can cause shifting problems due to the close tolerances between the valve and the bores in the body. Throttle valve TV cable on a 4L60. 4L60, so now they're talking about the kickdown cable. Kickdown cable in pretty much any manual transmission, it's going to be attached to your throttle body and also your throttle cable. So this one has a cruise control cable, this one has your kickdown cable, and here is your throttle actual pedal. So when you step on the pedal, this is the one that engages, this is the one that controls for cruise control. When you apply pressure to the pedal, when you go full wide open throttle, it's sending a signal to the computer manually by using this cable, and it's saying, hey, you know, it's kind of like a horse when you whack it like that. It's like, hey, we gotta go. This is what that cable is doing. It's actually pulling manually inside, engaging the valve body, which then makes it downshift into a lower gear, or higher gear, lower gear, you could say. And so if say you're cruising in third gear, you're like, oh, we gotta get up and go. When you step on the throttle, pulls that cable, it's like, hey, let's go, second gear. Shifts into second gear, you accelerate. So it's actually there to help, the throttle valve cable is there to help downshift when needing to accelerate. So we call it a kickdown cable, but a throttle valve cable would be the correct term to use. Vacuum modulator moves the modulator valve depending on the vacuum of the engine. A heavy load on the engine causes the vacuum to be lower than when the engine is operating under a light load. The spool valve applies mainline pressure to the boost sleeve of the pressure regulator valve, which causes the mainline pressure to increase. I know that's a mouthful of words. Let's see, vacuum modulator moves the modulator valve depending on the vacuum of the engine. Oh, okay, so when you are under heavy load, it doesn't want to shift the vehicle. The reason why is, let's say you're, a nice higher RPM, but under a real heavy load, you're pulling a trailer up a hill. The last thing you want to do is shift into a next gear, because remember, when you're accelerating, it's more for top speed. Higher RPM in a lower gear is meant for towing. That's why when you're driving with the trailer, you want to turn your overdrive off. You don't want it to go into overdrive when you're trying to go up a hill, especially like say the Cajon Pass or through the Grapevine. You don't want that to happen because you're going to be putting a lot of stress and a lot of heat going through that transmission. You can burn up the transmission. This vacuum modulator is to help control and keep that engine, or keep that transmission from shifting into overdrive. You can manually do it by clicking obviously on the overdrive button, turning overdrive off, or a lot of vehicles, especially depending on where your foot is on the throttle, it won't allow it to do so by using this vacuum modulator. A governor assembly is using older hydraulic control automatic transmission transaxles control shift points based on vehicle speed. So the output shaft is going to be sitting here inside this housing, which spins this plastic gear. As it's spinning, it's monitoring the actual pressure, the actual RPM of the output shaft on the transmission, which then can help control when the vehicle actually shifts. So it's watching to see how fast you're actually going, or how fast it's starting to accelerate. And by monitoring that speed of that rotation of the shaft, it knows, okay, we're trying to go fast, so let's hold off on our shifts, let us get as fast as we can, then shift into the next gear. The transmission range switch, or a rear-wheel drive automatic transmission mounted directly on the side of the case of the unit and accessible from underneath the vehicle. So this is actually a Prendle switch. When you shift into gears, or when you're manually shifting in each gear, first, second, even drive, overdrive, reverse, this module inside has the selector that this is what clicks through, so it knows what gear you're actually in, sending the signal to the computer. Then it says to the computer, hey, we're in first gear, or we're in drive, we're in third gear. So when you shift into, obviously going into first gear, right? It's going to stay in first gear. It's not going to upshift into the next gear or the next gear. But let's say you keep it in a third. When you keep it in the third, it's only going to allow you to shift up to third. You're not going to start off in third gear. You're going to start off in first gear. It'll shift in a second, it'll shift in a third, but it's not going to shift into any other gear after that. Then when you shift into drive, it'll go into fourth gear, and then obviously it'll go into overdrive if you have the overdrive switch on. So this is the range selector, which sends a signal to the computer, letting the computer know what gear it's actually in. Speed sensors are used by the powertrain control module or the transmission control module to control shifts and detect faults such as slippage when two speeds do not match the predetermined ratio for each gear commanded. You have your input shaft speed sensor, you have your output shaft speed sensor, solenoid connector, and the transmission range sensor. So these guys here monitor the speed. Let's say this RPM is a lot higher in the ISS speed sensor than the output OSS. So we know if this one's spinning faster, but this one's spinning slower, obviously we got an issue somewhere. We know that something's slipping, so now I can send a code to the transmission or to the computer and actually throw a check engine light. That's the beauty of technology nowadays. Say a customer comes in because their transmission's slipping. Back in the day, we had to reenact that situation. We had to make it slip. Sometimes the transmission will, sometimes it won't slip. This is actually going to help us further determine what's slipping and why. It can tell you, you know what, it was slipping in between second and third, and it happened at 40 miles an hour. Well, now we have all the information needed, so now we can condemn a transmission a lot easier. It's a lot harder to say, you know what, that transmission's bad when you can't get the problem to happen. Now we have documentation in the computer stating, the computer's like, you know, hey, this is what happened, this is why we need to replace it. Well, obviously it's not gonna say why we need to replace it, but this is why what we can tell the customer why we need to replace it. Between second and third is slipping. So obviously either the 2-3 shift solenoid or 3-4 shift solenoid is bad, and we need to either not replace the solenoid, but find out what parts went wrong with it. And usually we don't replace any parts, we don't tear it open. It's, you know, it's 5 hours labor to get it out. Pull the transmission out, might as well put in a new one. An example of a solenoid valve installed in a valve body assembly. So we actually have each one of these solenoids activates when power is getting sent through, which then sends the fluid through to another portion of the transmission, causing it to shift. So I'm not going to get too much into specific transmissions. It's just showing you, obviously, I know you guys have this in your book, so look it over, kind of get a good, you know, thought of, you know, basic fluid flow. So as a torque converter pushes fluid through, goes through into the transmission itself, goes through certain parts of the clutch, activates these clutches, sends power through this sun gear here, okay, and then sends power out. So like I said, I'm not going to get too deep into this, you guys. I don't want to try and, you know, confuse you. Same thing, second gear, third gear. So this is basically showing you the power flow for each gear. So first gear, second gear, third gear, fourth gear, in reverse. So if you guys have any questions, please let me know. Like I said, Monday, Wednesdays, and Fridays, I'm going to be doing our Zoom meetings. Monday, or the morning meeting is going to be at 9 o'clock, and the evening one's going to be at 7 o'clock. If you want to make both of them and go to be a part of both, feel free. But I still want you guys at least to do one every single time we do one. One each day. Please be still be doing your guys' questions. You know, at least 2 a day on SurveyMonkey. I'm going to start emailing or start texting you guys the link so you guys can do it just straight from your phone. I'm going to text you the link and I'm going to text you guys the questions. But like I said, if you guys have any questions, please feel free. Give me a call, give me a text, email me, carrier pigeon, whatever it takes you guys. All right, I'll talk to you guys later.